Hello student, I am Dr.A.K. Sinha, Professor of Chemistry. Today I am going to discuss geometrical isomerism. Last class I have started alkynes and I have finished that nomenclature of alkynes as well as structure of alkynes, means a double bond between carbon and carbon I have discussed, and in that also I have discussed structural isomerism. I have discussed structural isomerism by taking example of butane I have told. Then in structural isomerism of a butane, that 4 carbons are there, then butene, you can tell butene, then total 3 isomers was possible. Total 3 structures having same molecular formula was possible, means 3 isomer. First 2 was a straight chain, means carbon number 1, second double bond was there, then that is called BUT, but dash 1 dash in, and second carbon number 2 double bond was there, that's why it became BUT, but dash 2 dash in. Then these two are called position isomer, because double bond is just position only is changing. First time it was with carbon number 1, and in next structure that double bond went to the carbon number 2. Hence these two are the example of position isomer. And after that now butane is there, but you have written 3 chain and 1 branch, 1 carbon methyl group came in the form of branch. In the central carbon, means 3 carbon state and 1 carbon in the form of methyl group, it was attached with the center. Then now it became 2 methyl, because carbon number 1 double bond is there, after that middle carbon, last carbon, 3 carbon. Then with the center methyl group is attached, hence name will be automatically 2 methyl 2 dash meth prop, you can tell 2 dash meth, because methyl group is there, hence 2 dash meth prop, because it is propane, prop dash 1 dash in. Okay. Then this third is in the branch form. Third butane is in the branch form. Hence, first or third. First is a straight, third is branch. Then this is the chain isomer. Again, second and third. Second is a branch, third is chain. The second is a straight and third is in branch. That's again you can tell as a chain isomer. Okay, then two isomers states are called first and second, because a straight chain only carbon position is changing, that's why position isomer. And first and third, and second and third. First is straight, third is in branch, and again second is straight and third is branch. Then you can tell first and third and second and third is called chain isomers. Now I am going to discuss geometrical isomerism. Geometrical isomerism of alkene. Alkene means double bond. Now listen carefully. Doubly bonded carbon have to satisfy remaining 2 valence by joining with 2 atoms or groups. If the 2 atoms or groups attached to each carbon atom are different, they can be represented by y, x, y or x, x, y. Suppose these two groups are there. Two groups are attached with one carbon xy, other carbon again xy. Then this how this can give I can form two different structure. Suppose a carbon-carbon double bond is there. Then in the place of two hydrogen, now suppose two group attached, xy and other carbon also xy. Then this structure can give two type of isomers. This structure can give two type of isomers. What are that two types? That I am telling you now, that now it is a possible carbon-carbon double bond is there, and both carbon has xy, xy. Xy is considered as a different group. Then now two possibilities is there. Two possibilities there. First, both carbon can have one x adjacent to each other, means down. Both are suppose x, both carbon has x in the down position. That is the, you can tell, adjacent. Adjacent means close. And y is up. Both y is again close, but in up direction. Up direction. Then now this is called siege. When both group will be close to each other. Both are in different group, a different carbon, but both are close. Suppose both are down, x and x, adjacent or close, and y is again adjacent, means close. Then this is one type of a structure. This is called siege structure. CIS, siege structure or siege. And other, it is possible that now x can go up and y, one x can go up and other carbon y can come down, means cross. One x in one carbon x went up and other carbon y came down, means one x up, other y down. Then now two groups are not closest, both are different group. Now both groups are different. Adjacent groups are different. Upside also, down also. Or then you can tell that now they are cross, means one first carbon x is down, other carbon x is up, cross. And same way, y of the first carbon is up and y of the second carbon is down, then cross. This is called cross. Then this is called trans. Molecular formula is same, but now you can say they are arranged, they are differing in arrangement in a space. In a space, just to think upside down, suppose it is hanging in the air, just to imagine carbon. Then now say one situation was that both x was down and both y was up and carbon double bond. Then this is the first situation, that is you can say siege. Siege means both will be close, same group will be close. Adjacent carbon. And other, that one carbon x is down, other carbon x is up. Same way, first carbon y is up and second carbon y is down, means cross. Then these two structures are called siege and trans. Second structure is trans, when adjacent carbon has different group, correct? Then this is when different group means trans, or you can tell these things cross, just like you can say, you can tell middle, just like a diagonal you can tell. Diagonal means that is the trans. Either YY all are in the same diagonally and XX are diagonally. Then that type of a structure is called trans. And when both XX are close, YY are close, adjacent, that is called adjacent, that is called siege. Then there are two isomers, that is the trans and siege and trans isomers. Then the deeper arrangement in a space. Okay, the deeper arrangement in a space. Then now I have told you about the two ways. It can be represented in a space. In first I told you the two identical atoms, that is both the X or both the Y lie on the same side of the double bond. But in other structure, 2X or 2Y lie across the double bond, or on the opposite side of the double bond. Okay, this results in different geometrical isomer. Geometry also you can tell different geometry. Then here you can tell that disposition of atoms or groups in a space in the two arrangement is different. This result in different geometry, that is the disposition of atoms or groups in a space in the two arrangement is different. Therefore, they are stereoisomers. They are also called stereoisomers because in a space they are differing in arrangement in a space. Correct? That's why it is called stereoisomers. Stereoisomers, and siege and trans is the example of stereoisomers because they are changing their arrangement in a space. These are called stereoisomers. They would have the same geometry if atoms are grouped around carbon-carbon double bond can be rotated. But rotation around carbon-carbon bond double bond is not free. It is restricted. Already I told you that near the carbon, both end carbon, that hydrogen is there, that it can rotate. But rotation is not free. It is restricted. Then due to that movement, actually this stereoisomers forms or siege and trans forms due to this type of rotation. Okay, rotation around carbon-carbon bond is not free, it is restricted. Okay, this I have told you that both you can say geometry I told you. The stereoisomers of this type are called geometrical isomers. Okay, geometrical isomers. Stereoisomers is also called because it is coming under the geometry only. Geometrical isomers have two types of isomers. First, I told you this stereoisomers. First is the geometrical isomers, and second is optical isomers. Geometrical stereoisomers has two types: geometrical and optical isomers. Optical means related to light. Okay, because there be this optical isomers, they will differ in the behavior with light. Okay, then this I have told you This is this stereoisomers cis and trans is called geometrical isomers. Geometrical isomers. The stereoisomers of this type means cis and trans positions are called geometrical isomers. The isomer of the type, first type what I told, in which two identical atoms or groups lie on the same side of the double bond is called cis isomer, and the other isomers of the type, second type, in which identical atom or groups lie on the opposite side of the double bond is called trans isomer. Thus, cis and trans isomers have the same structure, but have different configuration, or you can tell arrangement of atoms or groups in a space. See, X and Y both are on the C carbon. X, Y is both at carbon 1 and carbon 2. Both X and Y are there, X and Y group. But that carbon 1 also X and Y have, and carbon 2 also X and Y have. But in a space it arrangement is different. Both X were you can say adjacent, and other case means both X were adjacent, both Y were adjacent, close. But in other, they were opposite. One X was up and other carbon X was down. It became a cross, trans, that is called trans. Just like a vertical way, diagonal way. Okay. Then these two I have told you that cis and trans isomer. Okay, I will try to send these two structure, cis and trans. Thus, cis and trans isomers have the same structure. Molecular formula is same, structure formula is also same, but they differ arrangement in a space. Sometimes X is up, sometimes Y is down. Correct? Like that way, it is not position, X and Y is not fixed. Just it is rotating, moving. X went up, Y came down. Like that way, that on the carbons, both carbon have same group. Means a structure is same, geometry is same, but they are differing in position. Up is coming down, down is coming up. That's why they are making two types of isomers, cis and trans. Due to different arrangement of atoms or groups in a space, these isomers differ in their properties. That's why, because in a space their arrangement is different. They need the two isomers and they will differ in their properties. Properties like melting point, boiling point, dipole moment, solubility. They have different solubility, different boiling point, melting point, dipole moment. Okay. Now I told about the cis and transform. Again, I will tell you more about the cis and transform. Cis form of alkene means a double bond. Cis form of alkene is found to be more polar than the transform. This is an important question asked in examination. Cis form of alkene is found to be more polar, means little charge will be there, more polar than the transform. Okay. For example, dipole moment of cis butane 2-1 okay, that two form is there. Butane has two forms, first cis, another trans. Then cis form, it's a cis form, we can tell but -2-in. It's a dipole moment is 0.33 dY, whereas dipole moment of transform is almost 0. Transform has dipole moment 0, but Siege has 0.33 dY. dY is the unit of moment, dipole moment. Then this important question I have told you. Now I am talking about the trans but dash to dash in is non-polar. 0 means what? Dipole moment is 0, means non-polar, but Siege has some charge, that's why it is polar. This can be this also can be understood by drawing a geometry of the two forms. Okay, I will tell you can show by arrow also, because in Siege but 2 in Siege but dash to dash in. If you want to show by the diagram, mu is 0.33 d. Then here in Siege form, carbon and hydrogen has some charge, del positive, del negative. Little charges there at both carbon. In butane means you can write CCH3, again CCH3, CH. CH3, CH, again CH, CH3, 4 carbon, CH3, 1 carbon, CH, second carbon, third CH, fourth again CH3. Then if you will see that first and second carbon, their they have little charge, positive and negative. You can show by the some arrow also. Dipole moment sign is there, that one arrow, and first and arrow and second and little cross will be there, just like a plus, okay, cross. Then like that way you can show both first and second carbon has a charge, and again third and fourth carbon has charge. Okay, and this trans butane, what you will see that now it is opposite. It is opposite, charge is developed, but is in opposite direction. Hence both are cancelling to each other and is becoming 0, because it is trans, diagonal. If it is coming, suppose east to west, up means up, east to west to east, and then down east to west. Or you can tell if it is a north to south, carbon 1 and 2, north to south, dipole moment is there. And carbon number 3 and 4th, that will be from opposite direction. North to south is first, then south to north. And both charge will be cancelled. Both are equivalent, charge is equal and opposite. That's why it will be cancelled due to the opposite position. Transposition. Both charge will be cancelled. It is developing in both Siege and trans, but in Siege both are from one side only, adjacent position. They are not cancelling, but in trans position it is cancelling because they are in opposite direction. That's why it is 0. In the case of solids, again you can say other things. In the case of solid, it is observed that trans isomer has a higher melting point. Trans isomers, because they are neutral, no charges there. Okay, no tension, nothing. Then trans isomers has higher melting point than the Siege. Siege there will be somewhat, because they are in one side only, adjacent. That's why some repulsion will be there. They can melt easily. But here in transposition both are opposite. Hence no forces are working, no tension, nothing. Hence melting point is high. Hence trans isomers have higher melting point and Cj are less melting point. Okay. And like that way, geometrical or Cis isotrans, actually geometrical isomers are also called Cis trans isomerism or isomers. Cis isomers, trans isomers, both are called Cis trans isomerism. And Cis trans isomerism is also shown by alkenes of the type, I am telling you two types. Here one type already you knowing, that other two types I am telling you that 2 carbon is there in alkene, 2 carbon is there. Then first carbon X and Y, two different groups are attached, and carbon second X is common. X is on the first carbon also, second carbon also. But in first carbon as a other group Y is there, but in second carbon as a other group Z is there. Only X is common in both, and both carbon has one different group, means carbon 1 Y and carbon 2 Z. Only X is common. Here you remember X is common on both carbon, and other group or atom you can tell both are differing. Both carbon have second group or second atom are different. One carbon has Y, then other carbon has Z. Hence you can tell with carbons, first carbon C, XY is there, and with second carbon it is XZ. Only X is common. Carbon double bond. This is the you can say one type. Or first type you can this first type already XY same. When both side groups are same, then that is the one type. This is the second type I told you, XY and XZ. And third type, now here will be, you can say, entirely different. With both carbon, different groups or different atoms are attached. As for example, with first carbon XY and the second carbon ZW, no common. Then this is another type of, you can say, Cis trans isomers. XY is there, first carbon, and second carbon ZW. Then this is also a type of Cis trans isomers. Okay. Then this I have told you about the distance geometrical isomerism. Okay. And one problem is there, I want to tell you. Problem is also easily you can understand, not difficult. But I am reading the question. Draw Cis and trans isomers of the following compounds. Also write their IUPAC name. They have given two compound 1 and compound 2. Compound 1 is CHCl, double bond CHCl. How it is easy you can understand. With carbon 1 H and Cl is attached. Carbon 2 again H and Cl is attached. It is just like what I told you, CXY again CXY. Same things are there. XY first carbon, second carbon also XY. Here also in the place of XY, H and Cl, again H and Cl. Then easily you can write its isomers. First you will write carbon double bond, first carbon down you write H, upside write Cl. 4 balance is over. Second carbon also you can write same way. Upside write Cl, down write H. then now down both H are adjacent. Both H or both Cl are adjacent. Then this is a Iitjee. This is a Iitjee form, Iitjee isomer. And other, what you will do? Other structure, other type, that any one H you write up and C you write it down. Then what will happen? Second type, you will write that H upar second carbon don't disturb. Okay, only first carbon you disturb, H up and Cl down. Then now see, H will be diagonal, trans. Cl will be again diagonal, trans. Then easily you can write this to a structure, Iitjee and trans. Then this is the answer of the first part, first compound. Okay. And in nomenclature you can do very easily because it is these things, carbon number 1 and carbon number 2. Carbon number 1 and carbon number 2, Cl is there. Cl, Iitjee. Both group are close, either up or down, whatever you can tell. Then Cl are adjacent. Carbon number 1, carbon number 2. Then its nomenclature will be first to write Iitjee because both are adjacent. Iitjee. After that 1, 2, 1, 2, 1, 2, what you will write? Dichloroethene. Double bond is there, that's why ethene. Then Iitjee 1, 2 dash dichloroethene. And now come to the second structure, what you have written? That is the trans is there, then you write a trans. Again same things. Trans, again 1 and 2. Then here what you will write? Trans 1, 2 dash dichloroethene. Okay, same name because now Cl is in trans position. First Cl was in a adjacent position. Now Cl is in trans, diagonal. Correct? Then they are far, you can tell. Far. Cl is far in the trans. Always in the trans, same group will be farthest. Means maximum far. But in Iitjee, both group will be close. Closest also you can tell. That's why second group nomenclature will be trans 1, 2 dash dichloroethene. Now second question is there, second compound. This is also same way. Compound is bigger, but same things are there. Means now in the place of H, suppose carbon double bond is there. Carbon double bond is there according to the question. Then in the place of 2 hydrogen both have ethene, have 2 hydrogen. Then now suppose with 1 hydrogen gone and its place methyl group came, and for other hydrogen went and its place ethyl group came. Means each carbon has 1 methyl group, 1 ethyl group. Each carbon has 1 methyl group, 1 ethyl group, and carbon double bond. Correct? Then now here 1 methyl group, 1 ethyl group, first carbon, second carbon, same way. Now it is very easy to write the Iitjee and trans. Both methyl group will write down, then ethyl group will go up. Both group ethyl group will go up, adjacent. Both ethyl group is adjacent, both methyl group is adjacent. This is the Cis form. And trans form, just any one carbon group, just you reverse it. Up you bring down, down bring up. Means suppose you have written ethyl group, both ethyl group you have written down. In the first case, Cis case, ethyl group was down, closest. Then in second structure, what you will write? C2H5 will go up and CH3 will come down. Then now it became trans. CH3 is on farthest distance, or you can tell C2H5 is farthest distance, diagonal. Then this is the transposition. Then very easily you have written cis and transposition. Then this type of question is asked, it will look big, but you will think in a serious way, and logical reasoning you will do, then you will get answer very quickly. And then what will be this naming, IUPAC name? Then same way what you have done with first, same way here. Cis structure, when you are writing, the first you write Cis. After that, every time I told you for the separation, dash you write. Cis dash 3, 4, because it is total 4 carbons are there. CH3, 1 carbon, with first carbon 2, 1 ethyl group is attached. Then how many carbons are there? Total carbon you can consider, then 2, 3, 4. 4 carbon total. First carbon CH3, that 1 carbon. After that it is attached with the carbon 2, and then C2H5 is attached. Then both side 4 these are there. Both side 4 carbons are attached. 4 carbon. Okay, both side. Then its nomenclature will be Cis, carbon number 3 and 4. Carbon number 3 and 4, dimethyl. Long chain you have considered, then you have to write 1, 2, 3, 4. Then 4 straight line, like that we can consider. Long chain means long chain you are considering. That is for these things 3 and 4. If you will consider long chain, then you will get carbon number 3 and carbon number 4 methyl group is there. Then you can write Cis dash 3, 4 dimethyl, diethyl, or you can write dimethyl ethyl. Better you write dimethyl ethyl, because carbon number 3 and 4 methyl group and ethyl group both are there. In both carbon 3 and 4 methyl is also there, ethyl is also there. Hence you can write Cis dash 3, 4 dash dimethyl ethyl 3 in, because carbon number 1 double bond is there. Carbon number 3 double bond is there. First, second, third. Long chain will consider, then first, second, third. Carbon number 3rd, that is a double bond. Okay. Then it will be 3 in. And same way, only use the word trans. Use the word for the second structure, use the word only trans, or thing will be the same. Means trans dash 3, 4 dash dimethyl ethyl. Okay. 3 in. Okay. 3, 4 dimethyl these things, same naming will be the same. Here carbon number you count it, how many total carbons are there. Then carbon number I told you that 2, 1, 2, 1, 2, 3, 4, Carbon number total will be one carbon and 2 carbon, 3 carbon. 1, 2, 3, 4. 4 and 4 to 6. 6 carbons are there, not only 4. 1, 2, 4, 5, 6. Okay. There, this is actually total 6 are there. Total 6. Okay. And long chain you will consider methyl group, you leave it, then C2H5 is there, both carbon C2H5, then 2 plus 2, 4 carbon, and 2 carbon is a carbon-carbon double bond, then 2 plus 2, 4, 4 plus 2, 6 carbon is there, and with carbon number 3 and 4, methyl group is attached. Carbon number 3 and 4. Okay. Then here total 6 hydrogen is there. Then it will be hex. Then nomenclature will be same way. Cis dash 3, 4 dimethyl hex 3 in, HEX. And here it will become same way, trans 3, 4 dimethyl hex 3 in, all things are same, only you have written cis because methyl groups are close, and in second methyl groups are farthest distance, that because it is trans, diagonal, then that's why it is a trans. Then nomenclature is same, only one case you write cis, other case you write trans. Okay. Then this I have told you about the, you can say, problem. How will you, I can say, write the isomers and nomenclature. Now one more problem is there. Which of the following compounds will show the cis-trans isomerism? They have given total 4 compound is there, and you have to find out which of the following compounds will show the cis-trans isomers or isomerism. Then first is with first carbon. With first carbon, 2 methyl group is attached with first carbon, CH3. Carbon ka ethylene only consider carbon-carbon double bond, but in the place of 2 hydrogen, 2 methyl group is attached with first carbon, and with second carbon only one ethyl group is attached, 1 hydrogen is there. CH2 was there and 1 hydrogen is attached as it is, but in the place of other hydrogen, ethyl group is there. Ethyl group. This is the first compound. Then, and the second compound, CH2 is there. CH2 double bond CBr2. This is the second. And third question is that, third compound, C6H5 is there, benzene, and 1 hydrogen, first carbon. And second carbon, 1 hydrogen is there, and 1 methyl group is there. And fourth compound, that 1 methyl with first carbon, 1 methyl group is there, and 1 hydrogen is there. And with second carbon, 1 chlorine is there, chlorine atom, and 1 methyl group is there. Correct? This I have told the question. that answer, but you have to find out which of the following compound will show cis-trans isomer. Cis-trans isomer. Then now I am telling the solution of the problem or answer. Explanation I am telling you. Third and fourth structure, compound third and fourth. In this will show structure third and fourth will show you can say isomerism. Cis-trans isomerism structure third compound third and compound third and fourth, it will show you can say cis-trans isomers. Why? Then here you can see with two groups are there, just like XY is there, na? XY and I told you XY and XZ, they can have isomers. XY with carbon XY and other carbon XZ. X is common, correct? Then it will show isomers. Then third will show isomers, cis and trans, and fourth also it will show, because fourth again XY situation there, CS3 and H is there, and again Cl and CS3 is there, means here again CS3 is common, CS3 is common, CS3 and one group is different. Then it will show the isomerism. One will cis and trans, both will show third and fourth. And what about the first and second? Then in a structure first and second, two identical groups are attached to one of the doubly bonded carbon atoms. Okay, means identical group should not be there. Identical group should not be there on the any carbon, either carbon number 1 or carbon number 2. Identical group should not be there. But here carbon number 1, 2-methyl group is attached with the first carbon, and second carbon 2 bromine is attached with the same carbon. Other carbon is okay, but one carbon of each compound, first and second, they have same group. Same groups is not required to show the cis and trans isomers. Okay, then this I have told you about the these things. Problems, what was the problems I have solved you, and in examination I am telling all the things because in exam this type of question are asking, particularly in advanced level, engineering advanced level or medical, this type of question is asking, generally they are asking. Okay, and the question has not, is little you have to think, difficult thing generally they will ask in advanced level. Okay, and little tough, not very tough in main or medical they will give mix, hard also and easy also. Okay, now I am going to discuss preparation of alkene. Then here first method is from alkynes. From alkynes means triple bond. Then it is very easy. A simple method is there. You can understand that triple bond is there, carbon triple bond, that is the alkynes. One hydrogen is there. Then if one bond will break, then two bond will be there, remaining two bond. Correct? Then from alkyne, it is very easy to form alkene, YNE, triple bond, alkyne. Then it is very easy to form alkene from alkyne. One bond will break and one bond involve 2 electron. And you know that out of three 3 bond, 2 bond is pi bond. 1 bond is sigma bond. Hence only pi bond will break. One pi bond will break, one electron, both carbon will take. Very simple way. And again, one hydrogen will come. Then now, which was CH, carbon triple bond. Now became CH2 double bond. Means from alkyne you will get very easily alkene. Then this is the first method from alkynes. Alkynes on partial reduction. Reduction means addition of hydrogen. Alkynes on partial reduction with calculated amount of dihydrogen, means hydrogen gas, in the presence of palletized charcoal, partially you can say deactivated with poisons, like sulfur compounds. Means here you can understand he requires charcoal, carbon you require. This must be palletized. Palladium, some particles should be there. And also this deactivated with poisons like sulfur dioxide. That carbon should not have sulfur dioxide as impurities. That's why it should be deactivated with sulfur dioxide. Generally with carbon, sulfur will be there, sulfur dioxide. Hence it should not be there. That's why it is called poison. Okay, poison. Then this is the requirement. Hydrogen gas in the presence of palletized charcoal, partially deactivated with poisons like sulfur compound or quinoline. Quinoline is also maybe there as a impurities. It will give alkenes. Here only condition you have to remember. Partially deactivated palladium charcoal is also known as what? Lindlar's catalyst. Question is asked. What is the Lindlar? Lindlars. Lindlar's catalyst. Then Lindlar catalyst. Lindlar's catalyst is palletized charcoal partially deactivated with poisons like sulfur compounds or quinoline. This is called Lindlar catalyst. Carbon you remember, PD you remember, and free from SO2. That's enough. That is called Lindlar catalyst. Question is asked. Fit for medical and main. Okay, IIT main. Alkenes thus obtained are having siege geometry. Here whatever will get alkene, that will be in the siege form. Means both group will be both carbon, same group will be this both carbon, you can say adjacent. I am talking about the groups, both HH or both RR, alkyl group. Suppose hydrogen gas was there. Hydrogen gas reaction took place with hydrogen gas, and alkyne was, suppose RC double bond against CR. Suppose this was the alkyne you have taken. R is the alkyl group, maybe ethyl group, maybe methyl group, maybe propyl or butyl, any group, or maybe long chain alkyl group also, short also. Okay, and suppose alkyne what you have taken, alkyne, that was suppose carbon triple bond was there, carbon triple bond, and R was attached. In the place of one H, R was there. Other carbon also in the place of one hydrogen, R was there, alkyl group. Then now hydrogen gas plus H2. This alkyne, YNE, this alkyne plus H2 in the presence of Lindlar catalyst. If reaction will take place, triple bond will convert to double bond, and H will join. Then both H will be, you can say, adjacent position. That's why it is a siege. Hence, what alkene you got? This is a siege alkene. You got siege alkene. And like that way, you can say other example also you can give. Alkyne. But now both carbon has different alkyl groups, R and R dash. R and R dash. Maybe R is equal to ethyl group and R dash may be methyl group or propyl group. Both are not the same. Plus H2. Then now again reaction will be the same. Only due to the alkyl name will be different. Compound name will be different. But now again they will form, you can say, alkene. Alkene they will form. But here you should remember this will be trans. This will be trans. But why? Because here catalyst is different. Catalyst is different. Here catalyst you are using sodium in liquid hydrogen. Sodium in liquid hydrogen. This here actually condition you should also remember, because product will differ. That time it was making siege. Both hydrogen was adjacent carbon. But now here both hydrogen went transposition, farthest from each other. Both hydrogen are in trans, farthest position. R and R dash is also trans. Obviously it will be trans. Then this alkene formed, got alkene, double bond. From the triple you got double bond. Then now it is trans alkene. Okay. Now third example I am telling you, ethine. Ethine means simple, very simple. Carbon triple bond and HH is there. Ethine. Acetylene is the best example. Ethine is also called acetylene gas. Then now this acetylene gas, one hydrogen only they have, both carbon and triple bond, carbon. Then ethine plus H2, it will form ethene. Ethene means carbon double bond. CH2 means C2H4 you got. But now catalyst is palladium and carbon only. Means ethine gives ethene. Now fourth I am talking of, preparation by the same method, means alkynes. From the alkynes, fourth method I am talking about. Propine you can take. Then it is very easy to write again carbon triple bond. With one carbon methyl group is attached, and other carbon only H was there, H is there. Ethene, CH, that is the CH type triple bond, then only one H is there. Then now in the that one H gone, and its place CH3 came. Then now 3 carbon was there, and other carbon only hydrogen was there as usual. Then CH3 C triple bond CH, three carbon has come. That's why now it is called propyne. In the place of one H, CH3 came. Other is only H only, already it is there, no change. Then this is called propyne. Then now plus H2, again hydrogen gas reacting with H2 gas. Then same thing will happen now. It will be no trans, no siege. This will be new compound general. CH3 already was there, no disturbance, only triple bond will break and it will convert to double bond, and HH will add in both carbon. Then there was no hydrogen was there, now one hydrogen joined, and one each carbon, one triple bond broken, then both carbon is taken one electron, and hydrogen has one electron, hence both joined. Then now it became CH3 CH CH2, CH3 CH CH2, CH and CH2. Now double bond is remaining, one bond broken. Then now it is called propene. Okay. Then this I have told you about the preparation. Other preparation is also there, but it will take time. Today it will not finish. Then I will discuss other these things preparation and these things properties. I will discuss in the next class. Okay. Thank you.